Hello there, this is Eustaquio of MEE21 and this is Basic Electronics Engineering Experiment Vlogs. So, let's go!
Let's begin now.
And in today's video, I'm going to discuss this. The Experiment 2 of semiconductor diodes and its characteristics. So, here are the objectives. First is to distinguish between the anode and cathode terminal of an actual semiconductor diode. Second is to measure the forward resistance and the reverse resistance of a semiconductor diode. Third is to test the conditions of a diode using a DMM and the ohmmeter function of a VOM. Fourth is to draw the characteristics curve of a diode both in the forward bias and reverse bias region. And fifth is to observe the actual behavior of a diode when connected in series and parallel. Equipment and components to be used. And since this is a online experiment, we're gonna use the multi-sim app or multi-simulator software. Here are the schematic diagrams. There are 6 given figures. Figures 1, 2, 3, 4, 5, 6. So here are the procedure. The first procedure is for the diode resistance. Number 1. Determine the anode terminal and the cathode terminal for the given diodes by looking for the markings. The marking signifies the cathode terminal. 2. Measure the forward bias resistance of the diode using the ohmmeter function of a VOM. See Figure 1 for proper polarities. Write the results in Table 1. Note: Asian testers have opposite polarities in the ohmmeter function. So we're gonna, instead of using Asian testers, we're gonna use the multi-simulator software. This one. So let's go to figures 1 and 2. As you can see here, these are the simulated circuit figures that has been given to us in the experiment 2 file. As you can see, this is figures 1 and 2. And these are the data that has been collected. So, after collecting the data from the multi-simulator, I input it here at table 1. So in diodes D1, the value is 35 mega ohms, and in D2, the value is 4 mega ohms. As you can see here, 4 mega ohms, 4.997. And in D3, it is 231 mega ohms. And since, as shown in figures 1 and figures 2, there are only 3 diodes that has been given in the experiment file. So I leave D4 and D5 blank. So that's it for the forward resistance. On the reverse resistance on D1, I have the value R, as you can see here, and in D2, the value is 5 mega ohms, and in D3, the value is 6.066 giga ohms. And since we located the values from the multi-simulator software, the condition is simulated. Okay, simulated and okay. Right. So That's for the diode resistance procedure. So let's go to the diode characteristics curves. Number 1. Connect the circuit in figure 3. Take note of the proper terminals of the diode and the power supply. Number 2. Measure the values for the voltage across the diode VD, voltage across the resistor or VR, and the current ID flowing in the circuit. Take note that voltmeters are connected in parallel while ammeters should be in series. Write the results in table 2. Then number 3. Repeat step 2 while increasing the voltage in the power supply up to 1.5 with 0.1 volts intervals. Number 4. We're gonna neglect that since we're using the multi-simulator app or software. So number 5. Draw in proper scale the diode forward characteristic curve using VD as the abscissa and ID as the ordinate. So we're gonna use also the multi-simulator to scale the diode forward characteristics later. I'll show you how. 6. Connect the circuit in figure 4. Take note of the suggested terminals of the diode and power supply. 7. Measure the values for the voltage across the diode VD. It is the same as number 2, but in figure 4, instead of 1.5 with 0.1 volts interval, in figures 4, it has an increasing voltage in the power supply up to 25 volts with 5 volts intervals. So let's go to tables 2 and 3. But before looking at tables 2 and 3, I'm going to show you the simulated circuit figures of figures 3 and 4. Here. This is figures 3. This is figures 4. So as you can see, I already put the values that I have collected from the multi-simulator here, table 2 and table 3, so that this video is not gonna eat up some time because it's difficult to upload videos with big file sizes. But I'm gonna show you the multi-simulated circuit first. So the instruction says that I should locate the voltage across the diode and the resistance, same as in figure 4. But gonna change the power supply's value from 0 to 1.5 with 0.1 volt interval in figure 3. In figure 4, it starts with the 0 but with 0.5 volt intervals. So these are the values. In 0, we got 0 VD, 0 in current, 0 in VR. I'm not gonna describe it one by one, sir, because it's gonna take too long. So I'm just gonna show the data that I gathered here. Okay, let's go to the characteristics curve. So this is what I have collected from the multi-simulator. So first, I'm gonna show you how I have been able to plot the characteristic curves, the characteristic curve of figures 3 and 4. So let's go to the multi-simulator. So first I'm gonna delete the multitesters, the ammeters. So the first thing that I did is to highlight the figure 3 first, then click simulate. Then go to analysis and simulation. Then go to DC sweep. As said earlier, the stock value is 1.5 and the increment or the intervals is 0.1. Let's check if the source is V1, V1, V1. Okay. And the output should be diode 1. Add. Run. So that's how I got the DC transfer characteristics from figures 3. So let's go now to figures 5 and 6. Here. In the questions, what is the voltage across the 1K ohm resistor? I was able to gather the data 11.599 nanovolts. And the current flowing in the circuit is 11.6 picoamperes. The conditions are simulated. Okay. So what happens when one diode is reverse biased in a series circuit? My answer to that is that the equivalent voltage and the current changes. In figure 6, what is the voltage across the 1K ohm resistor? It is 675.909 millivolts. The current flowing in the diodes in the circuit are 676 microamperes. The conditions are simulated and okay. So what happens when one diode is reverse biased in a parallel circuit? The DC transfer characteristics has a linear characteristic. And I'm going to show you the multi-simulated circuit figures of figures 5 and 6. That's how I found the values. Excuse me. The values of figures 5 and 6. Voltage of the resistors 1K ohms and the current. So that's it for the experiment 2 vlog video, and thank you for watching. Stay safe, sir. Stay safe, viewer. Thank you.